Hello and welcome to Unit 2 Variables and Expressions. You're working with Ms. Zampano on the section titled 2.4 Powers of Terms with Exponents. And we're taking a look at Pizzazz page 64. Oops, let's hold on. Going a little fast. Pizzazz page 64 is where we're going to take a look at these and make sure you put your name and date on this sheet. So if we take a look at this, we have some vocabulary that we've been working with already, and these are older vocabulary words from our 1.4 session. We also used these in our session previously on 2.3 of multiplying terms with exponents. So let's take a look. We've got some base and exponents, and each of these are components of the exponents that we've been working with. So these are terms with exponents. So we have a base, which is the term that's being expanded, the exponent, which is the power, the expanded form, which is the long way of writing it out using multiplication, and our exponential form of using the base and the exponent. So we're going to start off with the method for simplifying terms with exponents raised to a power. The first step is to simplify exponents from outside. So if we have an exponent outside the parentheses, we're going to want to simplify it by expanding what we have inside the parentheses. So this is when the step that will eliminate the outside parenthesis or the outside exponent, and it's only taking care of the outside power. So we really need to be cautious of that piece. So again, we're taking a look at terms that might look like, let me give you a brief example of what we're taking a look at. If we had 6x squared raised to the power of 3. This first step is simply telling me that I'm going to have 3 sets because of this outside power right here. That I'm going to have 3 sets of 6x squared. And I'm going to go ahead and write that in. So 6x squared times 6x squared times 6x squared. So this is that first step. Now we're going to go ahead from here and simplify by following the steps that we did for multiplication from last night's work on 2.3. So that was about multiplying terms, because now if you'll take a look, I have 3 terms that I am multiplying. I no longer have an outside exponent outside of the parentheses, and we can continue there. So a quick review of those steps would be to expand each term. So everywhere that I see an exponent now, I can go ahead and expand yet again to simplify within that. The next thing is to group the coefficients and the variables. And then similarly after that, I'm going to simplify by writing in the exponential form. Always making sure that I have the arrangement in alphabetical order. So this is the key steps that we're using. Again, the main point that we're going to recognize here is that we need to expand for that outside term, and then we can follow the steps that we used for multiplication. Let's take a look at a couple of examples. So our first example is 3x squared y to the power of 3. That entire quantity raised to the power of 4. So when I take a look at this, I'm going to have 4 different sets of this 3x squared y to the power of 3. I'm going to have 4 sets of that. So let's go ahead and expand out 4 sets of that. Alright, now I've taken care and have 4 sets of 3x squared y to the power of 3. And they're being multiplied together. And each and every single time, I have this idea where I have an x squared and a y to the power of 3, which can be organized in a specific way, But at first I want to just go ahead and to group these together. So let's group our coefficients to start with, and we have 4 different 3's. So we're going to have 3 times 3 times 3. And then I'm going to group, just to make it easy on my first example, the rest of my variables kind of each independently. And that's the situation when I grouped. Now I'm going to go ahead and say, okay, I've taken care of my coefficients. I want to expand from here what x squared y to the power of 3 looks like. And each time it looks like x times x and 3 y's multiplied together. So 3 y times y times y. So again, I have 4 sets of this, so let's go ahead and expand 4 separate times. And with this, I can then go ahead, I've done that expansion while I've grouped, and then I can say, let's multiply my coefficients, and then I can count the number of variables to find out what my new exponent's going to be. So my coefficient are the 3 times 3 times 3 times 3 in the very beginning, and I get 81. And I also take a look, and I have a number of x's. And I can count, so I use check marks to help me out, and I can count how many x's I have. In this case, it looks like I have 8 x's. So I'm going to have x to the power of 8. Because I'm multiplying, that's why I'm raising it to a power of 8. And I'm going to then do the similar situation with the y's. And it looks like I have 12 y's. So I'm going to have y to the 12th power. So my answer, when I take a look from my original idea of 3x squared y to the power of 3, the quantity of that raised to the power of 4. And when I take a look at that, my answer then is 81x to the power of 8, y to the power of 12. So this is a long process if we don't take it step by step. So my suggestion would be to take it very slowly and step by step. So the piece that we're going to go next is we're going to take a look at an example that looks a little less complicated. So the quantity of 8x to the power of 5, quantity squared. So if I do that, I'm going to have 2 sets of what is inside. So I'm going to multiply 8x to the power of 5 times 8x to the power of 5 and go ahead and expand. Then I just expanded. Whoops. Let's go back. So I expanded out, and each set I have x to the power of 5. So I'm going to write, by expanding those out, 5 different x's that are multiplied together. From here, I get to group my coefficients and my variables. So I'm going to take the 8 times 8 and put that in front, and then I'm going to put all these x's together. So I have 5 x's multiplied together in the first and 5 x's multiplied together in the second. 8 times 8 is 64, and all of those x's, there are 10 of them, are going to say x to the 10th power. So my answer of 64x to the 10th is this example. We have a couple more examples that we'll do together, and then a few that you're going to do on your own. Again, this step-by-step process works with the expanding out the outside exponent and then to expand the inside and group. So here we go, expand the outside, and then we expand the inside, and then we group together and simplify using exponential form. So those are some pieces that might make this a little bit more organized for you. If you want to figure out what's happening each step, you can absolutely write those pieces down. From here, let's take a look at example number 3 on the back. We're going to title our section again 2.4. powers of terms with exponents. So example number 3, we're going to start out with the quantity of negative a squared b squared, all raised to the power of 3. So the outside exponent is going to be the piece that I have that many sets of this. So for example, I'm going to have 3 sets because I have this exponent here that has raised to the power of 3. So that's going to tell me I have 3 different sets. So let's expand. There's my first set, my second set, and my third set. From here, I'm going to go and expand out what I have, and then I'm going to group. Noticing that in front of each of these, I do have a -1. If it's a negative variable, that really means that it's being multiplied by a -1. Now I'm going to go ahead and say, okay, perhaps I can do some grouping. So I've taken care of my coefficients, and I had 3 coefficients that had -1. And let's put the rest of our variables multiplied in the back. So I have 3 sets of a squared, b squared that I'm going to work with from here. And to help simplify this expansion, it's important for us to say that maybe mentally we can expand instead of having to expand written. So if I'm looking at this example right here, at a squared, b squared, I know mentally that if I square something, it really means like I'm taking that number and multiplying it by itself. So I have 2 a's multiplied each time and 2 b's multiplied each time. So an idea that I can organize is to just maybe make check marks instead of having to write all of the a's out. So organizing that, I can then say, well, hey, -1 times -1 times -1 gives me a -1. And I have 6 different a's. So I'm going to write a to the 6th power. And I have 6 different b's multiplied together. So I'm going to have b to the 6th power. Now, taking a look at this, I can write my answer as -1a to the 6th, b to the 6th. But it might also be helpful if I kind of ignore that -1 and just write as a -a to the 6th power, b to the 6th power. I would need to incorporate that there is a negative still in that answer. Let's move ahead to example number 4, where I have 3ab on the outside, and I'm multiplying it by the quantity of 2ab squared raised to the power of 4. Now this is important to take note of. This term in front that's being multiplied does not get the quantity raised to the power of 4. So that's going to stay all by itself, and I just kind of drop him in as though he's a separate term. I am going to have this section have 4 sets of 2ab squared. So let's go ahead and expand out. Leaving that first set alone and expanding 2ab squared, so I have 4 sets that are multiplied of that together, using just literally the identification of what it is to expand. From here, I'm going to go ahead and I can organize what my coefficients are going to be. I don't think, because I have so many terms, that it would be good to expand, so I might use my checkmark method that I used in example 3. Again, going ahead and organizing my coefficients first and then multiplying my variables at the end. Let's see what this looks like. So I'm going to multiply 3 times 2 times 2 times 2 times 2. And I kind of highlighted those in blue just to indicate the coefficient of each of the terms we're multiplying. Now let's go ahead and organize our variables. So when I take a look at this, I have 5 different a's that are being multiplied together. Now none of these a's has an exponent, so I just write 5 a's out. And then the b's, I'm going to identify in another checkmark method. Now I have one a in my first term that I highlighted in pink, and then each set that I have that I'm expanding has 2 b's in it. So I should write down 9 b's in total when I take a look, 1 from the first and 8 from the yellow terms. From there I can go ahead and write in an exponential form. So I want to multiply 3 times 2 times 2 times 2 times 2 and kind of organize what that looks like. And then I'm going to write a to the power of however many I have, so we'll count them, and b to the power of however many I have as well. So 64, a to the 5th, b to the 9th it looks like. So our answer of 64, a to the 5th, b to the 9th should be our answer. Sounds good. Now we have a couple of do-it-yourself, try-on-your-own problems. So let's take a look at those next. So for the try-on-your-own, they're example 5 and 6. We're going to start with 2x squared as our quantity raised to the power of 3. So make sure that you are expanding the outside exponent first, and then working to the inside exponent, grouping our coefficients and variables, and then simplifying using exponential form. The second example you'll try on your own is example 6, and I have the term multiplied out front of x squared times the quantity of 5x to the 3rd power raised to the power of 3. So I will be expanding the 5x to the 3rd power, 3 sets of that. From here, please try these on your own. I'll see you in class and we'll go over these two in class. Take care. Good luck.